Right. So this is Engineering Maths first year tutorial, the second tutorial sheet called Vectors. Question 1 is find the modulus of each of the following vectors. Okay, so the first one, we've got r is 8i plus 6j. What we say, we use Pythagoras to get this. The modulus of r is the square root, each one squared, each part component squared and added together. You do that on your calculator, it'll come up with the square root of 100, which is 10. B, the modulus of 21j, because j has got a modulus 1, you can just write that out as 21. So this is the general case when you get x plus yj. So the modulus of r, the square root x squared plus y squared. I can't simplify that anymore. This one, square root of r, is the square root of minus x squared plus minus y squared. So it's the square root of x squared plus y squared. And then this final one here for E, the modulus of this vector is the square root of 4 squared plus root 8 squared plus 5 squared, square root of 16 plus 8 plus 25, which is the square root of 49, which is 7. Okay, so that's those. There's the answers there, 10, 21, there, and there. Question 2. Write down the vector equation of the line passing through the points A, B with position vectors. OA is 5i plus 2j plus 3k, and OB is minus 1 minus 2j plus 5k respectively. Find the Cartesian equation of the line. Okay, so this line here, it goes through these 2 points, A and B. A is got coordinates 5, 2, 3. B has coordinates minus 1, minus 2, 5. Okay. And then we find the vector equation of the line. So we can start at the origin, like so. And we arrive at the line. And then we have multiples of the direction vector along the line. Okay. So the direction vector is A to B. So this is OB minus OA. So this is going to be minus 1, minus 2, 5, minus 5, 2, 3. So it's minus 6, minus 4, 2. Okay, so to go from A to B, I don't know why I put a double arrow there, we don't really need that there. To go from A to B, we move along in the direction minus 6, minus 4, 2. Okay, and then to get to the line, we have to move from O to A, which is 5, 2, 3. So the general point along the line, so it's 5, 2, 3, plus multiples of minus 6, minus 4, 2. And if we're varying the lambda here, it means we'll vary the place where we go along the line. So if we do half, if lambda's a half, we'll get there. That's lambda 1, lambda 1.5, lambda 2, etc. along this line here. Let's go back along this way, it'll be like minus a half, minus 1, minus 1.5, minus 2, etc. Okay, so that's the vector equation of the line. It's here. Okay, and to get the Cartesian equation of the line, that means we eliminate the lambda. So what you can say is R is x, y, z. So this is going to be 5, 2, 3, plus lambda minus 6 minus 4, 2. So we can say x is 5 minus 6 lambda. That's picking up these top bits here. Okay, so we can rearrange this. We can say that lambda is x, subtract 5 from each side, and divide by minus 6. Or you can say that is 5 minus x over plus 6. And you get that by changing the sign of everything. This is because we've got more minuses than pluses here. So we change the sign of everything, we just end it with one negative, the x there. So our y is 2 minus 4 lambda. So our lambda is y minus 2 over minus 4, which you can write as 2 minus y over plus 4. And our z is 3 plus 2 lambda. So therefore our lambda is z minus 3 over 2. So for the Cartesian equation of the line, because lambdas are now, this is a lambda, look, lambda equals this, and lambda also equals this. So therefore this equals this equals this. So we can say therefore 5 minus x over 6 is 2 minus y over 4, which is z minus 3 over 2. And that's called the Cartesian equation of the line. Okay. Oops. Right, part B. Find the vector and Cartesian equations of the line passing through the point A. Just keeping an eye on my answers here. Check I've got the right question. 1, 4, 5, which is parallel to the vector 2 minus 3 minus 2. Yeah. Okay. So we've got a line now. It passes through the point A, which is coordinates 1, 3, 5. And then it's parallel to 2 minus 3 minus 2. So what we can say, the vector equation is going to be r is 1, 4, 5. That gets us to the line. So we can say the origin is down here somewhere. Okay. And then the direction vector. Now we haven't been told 2 points, we've just been told the direction vector itself. So it's 2 minus 3 minus 2. So again, that's the vector equation of the line. Okay. Just don't have to do the B take away A like we did in the previous question. Then for the Cartesian, you can say x is 1 plus 2 mu. So therefore mu is x minus 1 divided by 2. Y is 4 minus 3 mu. So therefore mu is y minus 4 divided by minus 3, which is actually 4 minus y over 3. And then the last one is z is 5 minus 2 mu. So therefore mu is z minus 5 over minus 2, which is 5 minus z over 2. So for our Cartesian equation, the ones without any mu's in it, x minus 1 over 2 is 4 minus y over 3 is 5 minus z over 2. Okay. Sorry, I would underline by the side here. Cartesian equation of the line. That's there. Okay, next one. Right, vectors I and j form an orthonormal basis. Let's go to the for the xy plane. They are unit vectors, and mutually perpendicular, so they can be used to span the xy plane. Show that u, which is a half of I plus root 3 over 2j, and v hat, which is minus root 3 over 2i plus a half j, form an alternative orthonormal basis for the xy plane. Okay, so this wasn't in the course this year, so it won't be in the exam, but I'll do it for completeness. Okay, so to show that a pair of vectors are orthonormal. Oh, it's in the question, the one, right? I'll just say it's in the question. That you've got to show that the vectors are unit vectors and that they're mutually perpendicular. Okay, so unit vectors, to show that they're unit vectors, the modulus of u hat needs to be, the modulus of v hat needs to be 1. It's because u1 is the unit. So the modulus of u hat is, actually they don't use this underlined vector that I use. That's what they use at A level. They use an overline one. Yeah. Okay. So they don't need the underline as well as the hat one, which is fine. Okay, so the modulus of u, it's going to be, it's the square root of a half squared plus root 3 over 2 squared. So it's the square root of a quarter plus 3 quarters. So it's the square root of 1, which is 1, which is what we want it to be. We need to show that the modulus of each one is 1. Modulus of v, square root of minus root 3 over 2 squared plus a half squared. So it's the square root of 3 over 4 plus 1 over 4. So it's the square root of 1, which is 1. And then, so that shows that they've got unit vectors. For the mutually perpendicular criteria, we need to show that u dot v is 0, because the dot product, if the dot product is 0 between two vectors is 0, then it means the angle between them is 90 degrees, and that means perpendicular. And that's because the dot product, u dot v, size of u, size of v, cosine of the angle between them, cos 90 is 0. So if the dot product is 0, then the angle between the vectors are 90. So we've got, it's going to be a half root 3 over 2 dotted with minus root 3 over 2, 1/2. So it's a half times minus root 3 over 2 plus root 3 over 2 times a half. So it's minus root 3 over 4 plus root 3 over 4, which equals 0. So they are unit vectors. They are mutually perpendicular. So we can say hence orthonormal. Okay. Right, B. So it says represent A, the vector 3i plus 4j, in terms of the new basis vectors u and v. So u is, right, so u is a half. Just get this written down here. I plus root 3 over 2j, and v is Is it minus root 3 over 2i? Yeah. Plus it'll be a half j. Okay. So what we can say, if a, which is 3, 4, a is going to be a multiple of u plus another multiple of v. Okay, so we can say therefore 3, 4 is a1 times 1/2 root 3 over 2 plus a2 minus root 3 over 2 and 1/2 there. So we're going to say look at the the top components. So we'll get simultaneous equations. So 3 is a1 times 1/2 plus a2 times minus root 3 over 2. So multiply everything by 2, we actually get 6 is a1 minus root 3 a2. We'll call that equation 1. And then the second equation, 4 is root 3 over 2 times a1 plus 1/2 times a2. So again, multiply everything by multiply everything by 2. 8 is root 3 a1 plus a2, equation 2. So what we can do now, to get a1, we multiply, so simultaneous equations, got minus root 3 a2 there, plus a2 there. So if we multiply this by plus root 3, all these by root 3, we'll be able to simplify and get an equation for a1. So we do equation 2 times root 3 gives us 8 root 3 is 3a1 plus root 3 a2, equation 3. So then if we do equation 1 plus equation 3, we now get, let's just highlight these so we can see where they're coming from. That one, equation 1, equation 2, equation 3. Equation 1 plus equation 3, so we get 6 plus 8 root 3 on the left equals a1 plus 3a1 minus root 3 a2 plus root 3 a2. They cancel, and that's what we wanted them to do. So we can say 4a1, 6 plus 8 root 3. So therefore a1, 6 plus 8 root 3 divided by 4, and then divide top and bottom by 2. 3 plus 4 root 3 over 2. Okay, so that's one answer. Let's just change this colour here. That's A1. Is that there? And if we can substitute for A1 in 1, it doesn't make much difference. And we get 6 is 6 plus 8 root 3 over 4. Sorry, I should have used the simplified version there. 6 is 3 plus 4 root 3 over 2. So in equation 1, which is here, we've got A1 there. So 6 equals A1, and A1 equals this, so I've put that there. And then it's minus root 3 times A2. We can rearrange this to get A2. Okay, so let's multiply everything by 2 first of all. 12 is 3 plus 4 root 3 minus 2 root 3 a2. Therefore 2 root 3 a2 is 3 plus 4 root 3 minus 12, so which is 4 root 3 minus 9. So therefore a2 is 4 root 3 minus 9 divided by 2 root 3. Multiply everything by root 3. 12 minus 9 root 3 over 2 times 3, which is 6. Your calculator would actually do all this for you. Then divide top and bottom by 3. So it's 4 minus 3 root 3 over 2. That's a bit squashed at the bottom there. But anyway, we've got a2 is equals to this. So I'll just put the answer on the side here. Answer, we put it all together. Answer up here. We've got a1 is 3 plus 4 root 3 over 2. a2 is 4 minus 3 root 3 over 2. And so a is going to be 3 plus 4 root 3 over 2. I plus 4 minus 4 root 3 over 2. J. Okay, so this is a simultaneous way. I've solved it using simultaneous equations. There is another way in the notes, in the answer sheet as well, which is online, so you can have a look at that as well. Right, number 4. Okay, for each of the following vectors, use a scalar product. Just change that back again. Use a scalar product to find a vector in the xy plane which is perpendicular to it. Okay, so if it's perpendicular, then 1, 3, dot the n1, n2 equals 0. Okay, so the way that we can do this, we can have n1, n2, minus 3 and 1 there. So basically you swap these numbers round, and this is for the 2 by 2s, which is these ones here. Swap the numbers round and put a negative on one of them. Doesn't matter which one, because then if you look 1, just write this in here. There are many answers for this. There 1, 3, dot minus 3, 1. 1 times minus 3 plus 3 times 1, which does equals 0. Okay. The next one, you can say 1 minus root 2. It's going to be, so swap them round. 1, change the sign of one of them, which is automatically done, which I've already done because it's gone from minus root 2 to root 2 there, equals 0. Okay. I suppose using their notation that you've got at the start, if we use their notation, we can say they've called the normal R1, so we can say R1 equals the vector R1. Stop this. The hat is for unit vectors, so R1 minus 3i plus j. R1 for this one is root 2i plus j. So this one, we can go straight in and write it out. It's going to be, swap 4i plus 5j. Change the sign of one of them. And R1 for this one, it's going to be minus 2i. Okay. Just plug in here again. Okay. Yeah, so all of them you can check that if you do the dot product, the scalar product of this with the original, or this with its original, that one, or that one, it always comes up as 0. Number 5, find the scalar product of each pair of vectors and hence determine the angle between them. Okay, so the scalar product is A dot B, size of A, size of B, cos of the angle between them. Okay, so by that one, so we need to know A dot B is 1, 3, dotted with 1, 2, 1 times 1 plus 3 times 2, which is 7. So we've got that bit. The size of A is the square root of 1 squared plus 3 squared, root 10. So I've got that bit. The size of B, the square root of 1 squared plus 2 squared, which is root 5. Substitute them in and we get the cosine of the angle between them. So therefore we've got 7 is root 10, root 5 cos theta. So therefore cos theta is 7 divided by root 10 times root 5. So therefore, I think this has already been done here. We can get theta is cos inverse of 7 over root 10, root 5. And then when you do that on your calculator, it's 8.1 degrees. Okay, I'm not doing it on my calculator, I'm using the answers. I will do it on my calculator in case there's a mistake. Shift cos inverse 7. You can write that as square root of 50 just to be a bit quicker. In degrees, 8.1. Good. So again with this one, A dot B, size of A, size of B, cos of the angle between them. You can use radians as well. 19 pages, just seeing which page I'm up to, but anyway. So let's put these bits together. Right. A dot B. So it's 4, 5, dotted with 5 minus 4, which is 4 times 5 plus 5 times minus 4, which is 0. Now, if it comes up as 0 at this stage, you can go straight to saying the angle between them is 90 degrees because a 0 dot product means that they're 90 degrees between them. Okay? So that saves us a bit of time there. Right, C. Again, I'll write out here. Same for 3D vectors, which is what we've got here. Write it out enough times, you'll start to learn it. Okay, so exactly the same for these ones. A dot B, 3, 2, 1, dotted with minus 2, 1, 4. Okay, so this is 3 times minus 2, plus 2 times 1, plus 1 times 4. It's minus 6 plus 2 plus 4, which equals to 0. So we can say, therefore theta, the angle between them, is 90 degrees. And that's because of that 0 there. If it comes up at 0 at that point, then it's 90 degrees. So D. So I suppose we're doing this bit first of all. A dot B, 3, 3, 1, dotted with 2, minus 1, 6. 3 times 2 plus 3 times minus 1 is 1 times 6. So that is 6 minus 3 plus 6, which is 9. Okay, so let's go do the other bit as well. So the size of A is the square root of 3 squared plus 3 squared plus 1 squared, which is the square root of 18. Size of B, so it's the square root of 2 squared plus minus 1 squared plus 36. So this is the square root of 4 plus 1 is 5. That 36 came from 6 squared. I jumped the comma bit there. So it's 36 plus 4, 40, 41. Okay. So this other one here, this is 19. So it's 9 plus 1, which is 19. Excellent. Right, so therefore we've got 9 is root 19 times root 41 times the cosine of the angle between them. So cos theta 9 over root 19 times root 41. So therefore theta is cos inverse of 9 square root of 19 square root of 41. Type that straight into my calculator. 71.2 degrees. Okay. Right, that's number 5. So number 6 now. Given that F dot R is the work done by a force F in moving an object through displacement R, find the work done by the force F, which is 5I plus 4J. If it causes an object to move from point A to point B, 5, 1, 2 to 9, 3 minus 2. Okay. So first of all, we need to go from A to B. That's the displacement. So this bit here where they say the displacement R, that's going to be this AB. Okay. So this is going to be OB minus OA. So it's 9, 3 minus 2 minus 5, 1, 2, which is 4, 2 minus 4. Okay, so I've got to use green, I'll use another colour. So the work done is F dot R. This is our R. This is the R there, and then the F. Use another colour again. The F is here. So we've got R. R is equals to this. F, we've been told, is 5, 4. Now, because the R has got 3D, we need 3D here. It's 5I plus 4J plus 0Z is there. So the work done, I would say F dot R, 540 dotted with 4, 2. 4, 2 minus 4. Yes, this is correct. So it's 5 times 4 plus 4 times 2, which is 28. So the work done is 28 units. That's the answer. Okay, so let's get some colours in here. This blue, so this is the work done, which corresponds to there. And that one there, that was the orange one. Okay. Right, B. Obtain unit vectors in each of the directions of the vectors f, 4, 4, 2, s, 4, minus 4, 0, minus 3. Hence, find the work done. Right. Okay. So unit vector. So f is 4i plus 4j plus 2k. Okay. The modulus of f is the square root of 4 squared plus 4 squared plus 2 squared, which is 16 plus 16 plus 4, which is 36, which is 6. Okay, and then the unit vector, and we use this symbol hat over the f there. So that's the f divided by the modulus of f. So it's 4i plus 4j plus 2k divided by 6. We can divide top and bottom by 2, so it's 2i plus 4j, 2j plus k, all divided by 3. Okay, so that's the unit vector for f. Vector s is 4i minus 3k. The modulus of s is the square root of 4 squared plus minus 3 squared. Square root of 16 plus 9. Square root of 25, which is 5. S hat is s bar divided by modulus of s hat. So it's 4i minus 3k divided by 5. Okay, so that means that I've done the unit vectors for f and s, because that's here, that's the unit vector for f and the unit vector for s. Right, so hence find the work done in joules. The work done, if you remember in the previous one, was F dot R, and a force of 7 newtons in the direction of F moves its point of application a distance of 2 meters parallel to S. Okay, so the way this is the work done. Again, this isn't in the exam this year, so this is just for interest. The work done is, so it's 7 newtons times F hat, and then it's parallel to S, but 2 meters parallel to S. So that is dotted with 2 S hat. So that is going to be 14, and this is going to be 2/3, 2/3, 1/3, dotted with 4/5, 0 for the J, minus 3/5. And this is going to be 14, 2/3 times 4/5, plus 0, plus 1/3 times minus 3/5. So it's 14, and this is times 8/15, minus 3/15. So it's 14 times 5/15. That cancels to a third. So it's 14/3 of a joule. Okay, so that I'll just put that in where this colour comes in. So the work done, so the key bits is this, oops, that should be in a pink. That should be, it's the 7 and the 2, and then F and S. So it's the 7 and the 2, F hat and S hat. And that's the final answer there. Okay, number 7. Just got to keep an eye on these answers, just in case there is a mistake in the original answers. I'm trying to find that as well as do these ones. And hopefully we'll get them all sorted out. Right, so the cross product of the following vectors. There's 2 ways you can do it. I, J, K. And then you've got A1, A2, A3. Do it in a determinant style like this. A cross B. B1, B2, B3. Or you can do it like this, A1, A2, A3, crossed with B1, B2, B3, and that gives the answer A2, B3 minus A3, B2. And the next one is minus A1, B3 minus A3, B1. And then the last one is A1, B2 minus A2, B1. Okay, so I'll set it out. I'll do it both ways, and then you can see that they both work, and you can take your pick which way that you like. I think this way is the more traditional way. Let's do this with straight lines. So we can say the cross product so we go I, J, K, 2, 1, 3, 2, 3, 2. So it's going to be I, 1, 3, 3, 2, minus J, 2, 2, 3, 2, plus K, 2, 1, 2, 3. So this is going to be I, 1 times 2, minus 3 times 3, minus J, 2 times 2, minus 2 times 3, plus K, 2 times 3, minus 2 times 1. So I'll just explain where those numbers came from. This here with the i's is 1 times 2 minus 3 times 3. Then it's minus j, 2 times 2 minus 2 times 3. And then plus k, 2 times 3 minus 2 times 1. So this is I, and I'm just going to work out the inside the brackets here. So this is 2 minus 9, which is minus 7. Minus j, 4 minus 6, which is minus 2. And plus k, 6 minus 2, which is 4. This is minus 7i plus 2j plus 4k. And that one is correct. So that's the answer there for that first one. Next one. Right, the next one I'll do it this second way, and then you can watch both. It's up to which way you decide to do. So we're going to do it this second way. So it's 1 minus 1 minus 1 crossed with 1, 1, 1. So what we do is, with the first one, imagine crossing out, ignore the top row. So it's almost put a pen across the top row. And then it's minus 1 times 1 minus 1 times 1. Okay, minus 1 times 1 minus 1 times 1. Okay, and then, just about that one. For the second one, I'll just rip these out. For the second one, you ignore that row. So the coloured out row is ignored. Put an extra minus here, and then it's 1 times 1 minus 1 times 1. 1 times 1 minus minus 1 times 1. And then you think about for the third one, you cross this out, and it's going to be 1 times 1 minus 1 times 1. 1 times 1 minus 1 times 1. Okay. Now actually, all these figures here is exactly what's going on in here in these like matrix 2 by 2 determinants here. It's just a different way of setting it out, and it's up to you which one you prefer. I don't mind. So this is going to be minus 1 plus 1. This is minus, should be an extra bracket there. Yeah. So this is minus 1 plus 1. And this last one is 1 plus 1. So it's going to be 0, minus 2, and 2. Okay, so what you can say is minus 2j plus 2k. Okay, right, C, this one, I'll do, because there's not much in these ones, I'll just do these ones in the matrix thing, because it's not easy to see. It's a bit more writing, but it's easy to follow about. It stays on, it's easier just to watch what's going on with this one. So A is just a K, so we've got zeros in the I and the J. B is just a J, so we've got there, and there. So this is I, and it's 0, 1, 1, 0, minus J, 0, 0, 1, 0, plus K, 0, 0, 0, 1. Now what happens when you've got like two zeros there in a column in this? Look, because they're there, they come up in here and in here. So you get 0 times that minus 0 times that. That makes that 0 over all, and the same for that one. So if you've got a column of two zeros like that, then that's just automatically that equals 0 and that equals 0. So you didn't really need to write those down. So this is going to be, well, I just need a bit more room. B is K hat, let's just put B is K hat there. So this is going to be I times 0 minus 1 times 1, which is minus I. Okay. That's the answer there for A cross B for that one. Right, the next one, A cross B, is, so we do I, J, K. A is just a J, B is just a K, so put zeros everywhere else. And look, we've got that, yeah, that's right, we've got that column there, so we're only going to have, it's going to be like this one here. I times 1, 0, 0, 1. Then the other two, these ones here which came up 0, are also going to come up 0 in here, because the second one going to have 0, 0, 0, 1, and the third one you've got 0, 0, 1, 0, so they're automatically 0. So this is I times 1 times 1 minus 0 times 0, which is actually just I by itself. A cross B for that one. That's that one. Just going to see the question and the answer. Right, this one. So right in the IJK 3, 0, 4, 3. Oh, is that right? The same one. So is there 2 minus 1, 2. I times, and it's 0, minus 1, 4, 2, minus J, 3, 2, 4, 2, plus K, 3, 0, 2, minus 1. So it's I, 0 times 2 minus 1 times 4 minus j. 3 times 2 minus 2 times 4 plus k. 3 times minus 1 minus 2 times 0. So this is I times 4 minus j times 6 minus 8 minus 2 plus k times minus 3. So it's 4i plus 2j minus 3k. And that's our answer to that one. So that's there. That's A cross B. That's A. That's B. A bit messy these maybe. That's a question there. Another question there. That's the third one there. Okay. Number 8. How many are there in this question sheet? I think it goes up to number 10, 12. Number 8. Okay, if A is 4, 3, 2 and B is 2, 5, 1, calculate A cross B. Same as what we've just been doing. So I, J, K, 4, 3, 2, 2, 5, 1. 3, 5, 2, 1 minus j, 4, 2, 2, 1 plus k, 4, 2, 3, 5, I, 3 times 1 minus 5 times 2 minus j, 4 times 1 minus 2 times 2 plus k, 4 times 5 minus 2 times 3. This is I, 3 minus 10 minus 7 minus j. 4 minus 4 is 0. Plus k. 20 minus 6 is 14. So this is minus 7i plus 14k. Okay, that's the answer there. The first one there. B cross A. Two, 5, 1, 4, 3, 2. Okay. Which equals I. 5, 3, 1, 2. If you notice, what's happened here is like the two rows have switched. And you can, this answer will show you that you don't have to do all this working out, but I'll go through it and then we'll see the general rule in the end. J, 2, 4, 1, 2 plus K, 2, 5, 4, 3. So it's I, 5 times 2 minus 3 times 1. Minus j, 2 times 2 minus 4 times 1 plus k, 2 times 3 minus 4 times 5. So it's I, and then this is 10 minus 3, which is 7. J is still 0 like it was before, because it's 2 times 2 minus 4 times 1. Plus k, 6 minus 20 is minus 14. So this is 7i minus 14k. And so this here is the negative. If you look, it's the one above, minus becomes plus, plus becomes minus. So when you switch A cross B and turn it to B cross A, you could just switch the sides. But there we go. Right, A dot B. So this is going to be 4, 3, 2, dotted with 2, 5, 1. So it's 4 times 2, 3 times 5, plus 2 times 1, 8 plus 15 plus 2, which is 25. Another answer there. Number 9. B dot A cross B. B dot A cross B. So this is A cross B is minus 7I plus 14k. B is 2, 5, 1. A cross B is minus 7, 0, 14. So that's from there, minus 0, no J's, 14k's. Minus 7, no J's, 14k's. Which is 2 times minus 7 plus 5 times nothing plus 1 times 14. It's minus 14 plus 14, which is not. Okay, so there's a reason this has come up as 0. And I shall tell you now. Although I think this is part of, must be this one here. This is why I'm holding it. 9a. I think that should say 8d. Can you find, that's it. Can you give a reason for the result in, so look at 9a here, can you give a reason for the result in 8d, which is the one that we've just done here? So it's why is it 0? Okay, so A cross B gives a vector that is perpendicular to A and B. Okay, so imagine if we've got A, suppose we've got A there, B there. A cross B is perpendicular, so it's at right angles to the plane containing A and B. Okay, so then if you've got B dot, so we can say therefore B dot A cross B equals 0 because, and it's because here, I don't know if you can see it very, I didn't draw it particularly well, but there it's 90 degrees because A cross B is at 90 degrees to the plane containing A and B. Okay, so because of that 90 degrees there, because there is an angle of 90 degrees between B and the vector A cross B. So that answer is given above. So the answer to 9A is given above. So I've sort of done that one already in 8D. Okay, right, B cross A cross B. B cross A cross B. So this is B. I'll go back and do it that other way because I've got them like this. So this is 2, 5, 1 crossed with minus 7, 0, 14. So ignore the top for the first bit here. And it's 5 times 14 minus 1 times 0. So this is the other way that I mentioned of doing. You could, yeah, it's just because it's just the way I've been given the vectors. And then we look at the second one, and I always put an extra minus in there. 2 times 14 minus 1 times minus 7. Got my brackets right, good. And then the last one is 2 times nothing minus 5 times minus 7. 5 times 14 is 70. And then in here is this 28 plus 7, which is 35. So it's minus 35. And then 0, and that's 35 as well. Just checking my answers here. Yes. Okay. And that's all those done. Can you evaluate B dot A dot B? So if we tried to do this, B is 2, 5, 1. A dot B is actually the number dotted with 25, which is nonsense. We have to, because that is a scalar. A dot B, that's the scalar product, so it's got a scalar answer. It's a scalar. A dot B is a scalar. And we cannot evaluate a vector, which in this case was B, dotted with a scalar. It has to be vector with vector, so that's what's gone wrong there. Number 10. Points A, B and C form a triangle ABC. Find the interior angle at A. And I put scalar product there. It's probably to remind me to use the scalar product because there'll probably be a few ways of doing this. So let's draw this triangle. So we've got A, 8, 1, 3. B, which is 4, minus 4, 3. And C is 1, 1, minus 1. Okay, so the scalar product. Right, so we want to find the angle at A, so we'll call this one theta. Okay, this would be called C normally. It's called the lowercase letter, the lowercase of the opposite angle, so that's A. So what we do know from before, B dot C is size of B, size of C, cos of the angle between them, A, which we've called theta actually. So let me just put that as a theta just for... Okay, so we just need to work out our vector B. So our vector B is the vector that takes us from A to C. So this is going to be the C minus 8, 1, 3, which is minus 7, 0, minus 4. So let's see, to go from A to C, but the x's have to go down 7, the y's have to stay the same, and the z's have to go up, down 4, 3 to minus 1. Okay. So the size of B is the size of this, which is the size of this. So it's going to be the square root minus 7 squared plus minus 4 squared, square root of 49 plus 16. So it's 59, 65. Size of C now is the size of A to B. So B here is A to C. C is the vector that takes us from A to B. So this is 4 minus 4, 3, minus 8, 1, 3, minus 4, minus 5, 0. This is the square root of minus 4 squared plus minus 5 squared. So the square root of 16 plus 25, square root of 41. Check my numbers. 16 and 25 I can see. Yeah, that's okay. Right, so we've got enough now. We've got all the bits to put... Oh, no, we haven't. B dot C. So that is going to be minus 7, 0, minus 4, dotted with minus 4, minus 5, 0. Minus 7 times minus 4 plus 0 times minus 5 plus minus 4 times 0. So that's actually 28. So we've got all the bits now, look, because here we want B dot C, which we've got here, is 28. Size of B is root 65. Size of C is root 41. So substituting it all in, I'll write the equation again because it's all a bit of a mess up there. See, cos theta. So therefore 28 root 65 root 41 cos theta. So therefore cos theta is 28 over root 65 root 41. So therefore theta which is cos inverse of all that. I'm going to do it on the calculator now. Shift cos inverse. 28 on the top, root 65 times root 41, 57.2 degrees. That's our answer there. Right, so we've got the same triangle. I'm just going to plug this in just to make sure that I've actually run out in the middle of the question. Should be annoying. Right, so we've got the same triangle. Use the vector product to find the area of the triangle. So the vector product is going to be a half B modulus of B cross C. Okay, that's what you from before, and B is minus 7 naught minus 4, and C is minus 4 minus 5 naught. Okay. Yeah, so this comes because the vector product, a little bit of the theory here in the side, which you don't need, but just sort of feel like I've put that out mid-air and want to tell you why. A cross B is size of A, size of B, sine of the angle between them, times a normal to the plane containing A and B. So the modulus of A cross B is modulus of A, modulus of B, modulus of sine theta. Okay, because the modulus of n hat, because when it's a hat, it's a unit vector. Is this right? And then, if you remember from GCSE, the area of a triangle is a half AB sine theta, an angle between them. Okay, so if you do a half of A cross B, it's a half of modulus of AB sine theta. So that's the area of a triangle. So that's what you was told at GCSE. This is the one that you've got now from A cross B. Well, that's A cross B. And then when you take the modulus of that, it's the modulus of each part multiplied together, which is that one there, which is there. Okay, so this. So we need to do, it's going to be a half times the modulus of B cross C. So I'll start by doing them B cross C, and then we'll do the half bit first of all. B cross C, I, J, K, minus 7 naught, minus 4, minus 4, minus 5, 0. So I'm just doing what I've done lots of times already. And then plus K. Naught times naught, minus 5 times minus 4. Minus J, minus 7 times naught, minus 4 times minus 4. Plus K. Minus 7 times minus 5 minus 4 times 0. So this is I, and then that's going to be minus 20, minus J, minus 16, plus K, that's going to be plus 35, minus 20I, plus 16J, plus 35K. And then the modulus of B cross C, so this will be the square root of minus 20 squared plus 16 squared plus 35 squared. Which I'm now going to do on my calculator. So it's 400 plus 16 squared plus 35 squared, 1881. Yep. So it's the square root of 1881. See if that's got a nice, which is 3 root 209. So the area of the triangle ABC, it's 3 root 209 over 2. Right, that's the answer. So I'm rushing on there. Okay, that's the triangle there. Right, number 11. Find the vector products of A and B. A cross B. I, J. You still got to put K in because the answer will have K's in. It's 2, 3, 0, 5, minus 1, 0. I times 3 minus 1, 0, 0. So those ones are automatically 0 because of that 2 zeros there. Minus J, 2, 5, 0, 0. Plus K, 2, 3, 5, minus 1. So because of these 2 zeros here and here, like I've discussed before, they're both equals to 0. So this is K, 2 times minus 1, minus 5 times 3. It's K minus 2 minus 15, which is minus 17. Okay. So, comment on your answer. So what I think there, the comment, should be that the vector product of A and B is going to be a vector that's perpendicular to the plane containing A and B. Now, because the plane contains A and B are made up of I's and J's only. So if this is I, this is J. So I suppose that's I, I'll just do this a bit bigger. That's a J. Okay, so it's going to be a K, because K is perpendicular. Because these have just got I's and J's in here, so it's got to be made up of K's. Okay, so that's what's going on there. Find a unit vector perpendicular to 2i plus j and 3i minus 2j. So again, we'll do A cross B for a vector perpendicular to A and B. So as before, it's going to be just the K one that comes up because of those double zeros. Oops, put my bracket in the wrong place there. Times 1. Minus 4 minus 3 minus 7, which is minus 7k. So the unit vector, so if we've got A and B in here, both A's that way and B's there in this plane. So we've got minus 7k. Feels like I should draw it that way. It doesn't actually matter. Okay, so the unit vector is, so this vector here, the answer that we've got has got length minus 7, because k is a unit vector already. Okay, so the unit vector perpendicular to A and B, it's going to be k. It could also be minus k, because so it's just k that way, or minus k, which is just 1/7 of the answer there. Okay, now we didn't need to do this working out because we could see these are made up of just i's and j's, so the answer had to be, well, the answer to the cross product is going to be a multiple of k's, and then because it's a unit vector, it's just going to be 1k or minus 1k. Okay, and 12, A and B, and then we'll be done. So A, find the vector and Cartesian equations of the plane which contains the point A, 3 minus 2 minus 1. I feel a diagram coming on there. So it's 3 minus 2 minus 1. And it's so that lies in the plane, and it's perpendicular to 4, 2, 1. Okay, so what happens here when you've got a normal to the plane and a point in the plane? What you can have is, well, basically you have R dot N is D. Okay, and D is actually A dot N. Okay, so that's in the notes where that comes from. And R is X, Y, Z. And the normal is 4, 2, 1. So this is 3 minus 2 minus 1, dotted with 4, 2, 1. So therefore 4x plus 2y plus z. 3 times 4 minus 2 times 2 minus 1 times 1. So we have 4x plus 2y plus z. 12 minus 4 minus 1, so it's 12 minus 5, which is 7. Okay, and that is the Cartesian equation. That's how you get that one. So the Cartesian equation there, so I've done that bit there, and you get that by doing R dot N is A dot N. R is the X, Y, Z, N is the normal, A is the point in the plane, and the other N is the normal. So R, X, Y, Z, normal there, and that's the point in the plane. You end up with the Cartesian equation. Okay. The vector equation of the plane, I think that's just I've sort of done that already in this one. Vector equation of the plane is just keeping it in vectors, X, Y, Z, dotted with 4, 2, 1, equals 7. I can say R dot 4, 2, 1 equals 7. That's the vector equation there. Let's do that in a different colour. It's just keeping it into a vector on that left-hand side. Okay. And then the last bit that we need in here, the perpendicular distance of the next one here, the perpendicular distance of the plane from the origin. Okay. So this one, the perpendicular distance, to do that one, it's A dot N divided by the size of N. Okay, so A dot N is 7, and then the size of N is the square root 4 squared plus 2 squared plus 1 squared. Okay, so it's 7 over 16 plus 4 is 20, 21. 7 over root 21. That on your calculator, that will simplify. So that's 7 over root 7 times root 3. So it's root 7 over root 3. And that's the green answer there, perpendicular distance, and that's the formula that you've got to use for that one. Okay. And then the last one, part B. A plane has normal n 2i minus 2j plus k. And it's a perpendicular distance of 3 from the origin. What are the vector and Cartesian equations of the plane? What is the perpendicular distance of the plane from the point B is 1, 3, 2. Okay, so what we've got, the vector, so what we've got, vector and Cartesian equations of the plane. So we've got, so the normal in the top line is 2i minus 2j plus k. The perpendicular distance of 3 from the origin, so using what I've just told you on the previous page, a dot n over the size of n is 3. Okay, we can get the size of n here actually. Size of n is 2 squared plus minus 2 squared plus 1 squared. So it's the square root of 4, and 4 is 8 and 9, which is 3. There we are. So a dot n over 3 is 3. So therefore a dot n equals 9. Okay. I've used that. So let's just underline this bit here. So what we have now is, for the vector equation of the plane, r dot n equals a dot n. So this implies that r dot 2 minus 2, 1 equals 9. Okay. And then to get the Cartesian equation, so that's the vector equation. To get the Cartesian equation, replace the r with x, y, z. Times with 2 minus 2, 1 is 9. So therefore 2x minus 2y plus z equals 9, and that's the Cartesian equation of the plane. Let's do some colouring in here. So the vector equation, well, I suppose that's a vector as well. They're vectors. Or that one could be a vector equation. Okay, and then this one is the Cartesian equation, which is there. What is so these top blocks here, these top two bits here, this is just like working out. This is just what I've used here for working out. Okay. What else have I got to do? Right, what is the perpendicular distance of the plane from the point B? 1, 3, minus 2. Okay. So, if we can say, I'll just go, right, so I'm just going to write this on a new page. So what is the perpendicular distance of the plane from the point is it? From the point, on the other side, 132. And the plane that we've got so far is r dot 2 minus 2, 1 equals 9. Okay. R dot 2 minus 2, 1 equals 9. Okay. So, somebody's just at the door just then. Oh, I'll go back to see him in a minute. I think they've gone. What is the perpendicular distance of the plane from the point 1, 3, 2? Just thinking here, I've done this for a while. Okay. So, we've got a plane. The origin here. Perpendicular distance from the origin is 3. Okay, so where that makes a right angle there, that's 3. So we need it from perpendicular distance of a plane from another origin, from another point is from a new point 132. So we need to know this second thing here. So it's 9, 13, 14. So I'm just thinking out loud here. Okay. So if we imagine, right, if we make, I've got the idea now. So this is from the origin, it's 3. If we make this 132 the new origin, so we'll do that by shifting the plane by -1, -3, -2. Then the distance from that shifted plane to 132 is going to be 3. Okay. So we've got, if we shift the plane by -b, which is -I -3j -2k. Okay, then we've actually got r dot n now is, so instead of r dot n equals 9, it's going to be a minus b dot n. Okay, because the point that was on the plane, which we just called A there, it's going to be, is r dot n is A. So it's been a bit slow here. R dot n is A dot n, is the vector of the plane. But because we're going to move a bit by 132, so we do r dot n is A minus B dot n. So this is for the new plane. Okay. So this is A dot n minus B dot n. And so the distance of the new plane from the origin, which is now, if you like, 132, from the origin is, so it's A minus B dot n divided by the size of n. So it's A dot n minus B dot n divided by the square root of 2 squared plus minus 2 squared plus 1 squared. Okay, and A dot n from this side is 9. So it's 9 minus b, which is 1. What I've done here, or what we've done here actually, is I've put the minus, I've used the minus there, but I've put it outside there. So in here I've got to put positive ones again. So 1, 3, 2, dotted with 2, minus 2, 1, over the square root 4 plus 4 plus 1, which is 9. So this is 9 minus 1 times 2, plus 3 times minus 2, plus 2 times 1. All divided by the square root of 9 is 3. Let's tidy this up a little bit here. Okay, so it's 9 minus, so this is 2 plus minus 6, which is minus 4, plus 2, which is minus 2, all over 3, which is 11/3. Okay, so that's the answer there, and that took me longer than I thought it would. Okay, so I'll stop recording there. Just having a little think there. I think might be a quicker way of doing this. Anyway, no, just leave it like that for now. Again, that would be a bit too much for an exam, so don't worry too much about that one. Scruffy, don't like that line. Finished. Okay, so that's the